Here's number 2 from the practice of the law of cosines. It says a pilot flies in a straight path for an hour and a half. So moving along this way, 1.5 hours. And at some point they tell us that they're going 365 miles, 635 miles an hour, right? So 635 miles per hour. After that amount of time, then the pilot, it says she then makes a course correction heading 10 degrees to the right of her original course. So if that were to continue on, the new course is now coming down here 10 degrees. Okay, that's not 100, that's at 10 degrees. And that's now for 2 hours, still at 635 miles per hour. So I can find out how much, how far, how long each of these distances are, because 2 times 635 is what's 1270 miles, and 1.5 times 635, 952.5 miles. So I know those two distances, and I know this angle. If that's 10 degrees, then this is 180 minus 10, so 170 degrees. And the question is, how far is she from her starting position? Well, if she started here and ended there, well, then they're asking for this distance right here. Let's call it A. Well, that looks like a law of cosine problems to me, that A squared is 952.5 squared plus 1270 squared minus 2 times 952.5 times 1270 times the cosine of the angle in between. And then A is the square root of all that. And all that is equal to, and this is 4902750.887. And if I take the square root of that, I get 2,214.2156, whatever, miles. I do a little bit of a reality check in that if I just add these, if she just kept going in a straight line, then the total distance would have been 952.5 plus 1270. It would have been 2222.5, and this is 2214. So it's a little bit less than if it had gone in a straight line, which makes some sense because going in a straight line would have been the maximum distance apart, but this is a little bit less than that. So I'm pretty confident that that's the correct answer.